Welcome to the presentation on AI Mathematical Olympiad 2025 Bronze Medal Solution. I am Professor Kumar from the Department of Computer Science and Engineering, Defense Institute of Advanced Technology. The overview of this presentation is as follows. I'll be giving a brief introduction to the AI Mathematical Olympiad, describing the competition, then the data sets used in this competition, the solution overview, how we select the model and how we configure it, the details about vLLM, some details about the prompt engineering which is used in the solution, the techniques used for time management, and finally answer selection and submission, followed by the conclusion. I'm glad to note that I won the bronze medal in this global machine learning competition organized by the AIMO, that is Artificial Intelligence Mathematical Olympiad. This is a Progress Prize 2, which was held on 2025 and concluded in the first week of April. Let us now discuss about the AI Mathematical Olympiad 2025. The goal of this competition is to create algorithms and models that can solve quick, tricky math problems, which are in the LaTeX format. These are national level math challenges which are solved by the AI models proposed by the participants in this competition. This is supposed to help the advance of AI models, mathematical reasoning skills, and drive the frontier of knowledge. In fact, this is the second AIMO Progress Prize competition. It builds on the first AIMO Progress Prize competition, which was won in July 2024 by Project Lumina. This competition has an increased prize pool. It has a new data set of problems and increased compute for the participants. Also some updated rules for using open LLMs. So the ability to reason mathematically is critical milestone for the AI. In fact, mathematical reasoning is foundation for solving many complex problems, from engineering models to intricate financial models. The current observation is that AI models' capabilities are limited in this area. So in fact, AIMO, the AI Mathematical Olympiad Prize is around $10 million. It is supposed to spur the open development of AI models which are capable of performing well as top human participants in the Mathematical Olympiad. So this is the second AIMO and has around 110 math problems which are covering the areas of algebra, combinatorics, geometry, number theory. In fact, the difficulty has been increased from the first competition. The problems are now around National Olympiad level. The problems have been designed to be AI hard. That means which is in fact tested against current open LLM's capabilities. To address the challenge of trying test leakage, the competition uses novel math problems created by international team of problem solvers. So this uses transparent and fair evaluation framework. The competition will in fact help strengthen the benchmarks for assessing AI models, mathematical reasoning skills, without the risk of contamination from the training data. So in fact, this is an exciting opportunity to drive innovation in the field of AI math. It also fosters healthy competition and supporting open science. So the evaluation in the competition The submissions which are by the participants are evaluated on the accuracy, so between the predicted labels and the ground truth labels. So submissions are ranked by fraction of predicted labels that are exactly matching the ground truth labels. So every ground truth label is between 0 and 999 inclusive. So the solution obtained may be computed with modulo 1000 to bring the number between 0 to 999. Supposing the solution is 65,521, then it should be reported as 521. Um, and 900, for example, minus 100 should be reported as 100 after taking the modulo 1000. Then so the computations required, or some of them are shown here. So the prize fund is around $2 million, and top winning teams get so much of um, prize amount. Like the fifth place is 16,000, fourth place is double that, and third place is 65,000, like that. The highest prize amount is 260,000. Overall progress prize winner is also announced, and the highest ranking team that achieves a score of 47 by 50 on both public and private test sets. However, this has not been achieved in this current competition. The code submission requirements as per the competition rules are that the notebooks need to be submitted, which consist of the Python code, and the CPU notebook should be less than 9 hours runtime, and GPU should be less than 5 hours runtime. There is no internet access provided during the competition running of the notebooks. So also data sets which are freely available or can be used for pre-trained models. Submission file must be generated by the API. Submission runtimes are obfuscated, and the participants may not know exactly the time their notebook has taken. So the submission should be through the API, Python API, and the test instances are presented to it one by one in random order. That means a participant whose notebook is running may get questions randomly from the set of questions there. So the requirement, one of the other requirement is that the prediction server must be called within 15 minutes, and the submission notebook should be that it should return the response within 30 minutes. So the data set, the competition data is around 110 mathematical problems which are on the International Math Olympiad style. The answer to each problem is a non-negative integer between the 0 to 999. So one can take the modulo 1000 for the solution to get the number between 0 to 999. Then so these are at the very high level math problems, and all the problems are presented in the mathematical notation of LaTeX. So, and for geometry problems, the diagrams are not used in the problem. The public test set comprises 50 problems, and the private test set comprises of 50 problems. And 10 problems with solutions is provided to the participants so that they can check their models. So let us now look at International Mathematical Olympiad, which is one of the most interesting and the popular competition which is held for the high school students annually. And the IMO moves from one country to another every year and attracts thousands of participants. And I am showing you some of the problems which are presented in 2005 IMO. So there are 6 problems which the participants have to solve, and then the gold medals, silver medals, and other medals are awarded. So one of the example problem we have been selected from the 10 uh, problem data set provided by the organizers is shown here. This is problem number 10. The Fibonacci numbers are defined as f0 is equal to 0, f1 is equal to 1. So fn plus 1 is equal to fn plus fn minus 1 for all n greater than or equal to 1. So there are in fact n positive integers which are less than 10 to the power of 101, such that n square plus n plus 1 whole square is a multiple of 5, but fn minus 1 square plus fn square is not. So we need to find out how many prime factors does n have counted with multiplicity. So the PDF provided by the competition host also has the solution, which is shown here, step-by-step solution, and the final answer which need to be provided. So we now go ahead and present the bronze medal solution details. So this consists of sections such as selection of the model, time management, voting mechanism, prompt engineering, how did we test and validate the model, and how the final notebooks are submitted, and the final scores. So the selection of the models, what we did is we checked several models which could be used in the notebooks. In fact, there is only one submission per day which is allowed, and in this regard we slowly built up the knowledge about different models and how they are able to handle this problem. One of the model I selected is the open source DeepSeek R1 Distill Quen 7B. So this model is shown on all the benchmarks here, and it is shown to perform extremely well compared to all other competitive models. So in this competition, we are not supposed to use commercial models, we are only supposed to use open source models. So in this regard, this model comes a very handy one. We also use the open source vLLM to ensure that the LLM is handled, and this vLLM is a framework which is fast and easy to use library, and it helps load the LLM and does inferencing and configuration, etc. So I am giving you some details about vLLM. It is one of the best tools to run DeepSeek models efficiently, and especially the 7 billion parameter variant. So vLLM is an open source high performance LLM inference engine and developed by the UC Berkeley. It is fast, memory efficient, and scalable generation. It uses paged attention. So fast inference, vLLM optimizes memory with page attention, giving faster token generation. Multi-query batching, one can run hundreds of concurrent prompts efficiently. Streaming and API, so it serves DeepSeek as fast as a fast backend for chatbots, agents, RAG systems, and it uses very low memory and runs the 7B models on a single 24 GB CPU using quantized variants. So long contest support, it supports DeepSeek in long contest versions like 32K plus tokens. So vLLM is very flexible to use. It has seamless integration with popular Hugging Face models, high throughput serving with various decoding algorithms, including parallel sampling, beam search, etc. It also provides tensor parallelism, pipeline parallelism, support for distributed inference. It also supports streaming outputs. It's OpenAI compatible API server. It supports NVIDIA GPUs, which are used in this particular competition. It has prefix caching support and multi-loader support. So now the model which we have selected is the DeepSeek R1 Distill 7B AWQ. DeepSeek R1, which is incorporating cold start data with the reinforcement learning. So DeepSeek R1 has achieved a high, very good performance, which are comparable to some of the best models on math problems, coding problems, and reasoning skills. So in order to support the research community, the open sourced DeepSeek R1 0 and DeepSeek R1 and 6 dense models distilled from DeepSeek R1 based on Llama and Quen are available for the users. And it has been shown that DeepSeek R1 Distill Quen 32B outperforms even the best OpenAI models. So the larger models can be distilled into smaller models, and which results in better performance. That is the core idea of the distillation. And the open source DeepSeek R1 as well as its API is supposed to benefit the research community to distill better smaller models in the future. So the data generated by DeepSeek 1, several fine-tuning has been done for the dense models. The evaluation results demonstrate that distilled smaller dense models perform exceptionally well on various benchmarks. So DeepSeek have open source 1.5B, 7B, 8B, 14B, 32B. These are the 7B and 14B have been very popular among the participants in this competition. So this DeepSeek R1, these are open source LLM provided by DeepSeek AI. It comes with different sizes as we have discussed for optimized for reasoning, code generation, and NLP tasks. It supports multilingual capabilities, and the distill refers to the distillation, a process where a smaller model is trying to imitate a larger one. It helps in compressing large models like DeepSeek R7B, Quen 7B into more efficient versions while retaining most of the performance. 7B refers to 7 billion parameters, which is supposed to be a common sweet spot between capability and hardware efficiency. And AWQ refers to activation aware weight quantization. So this enables faster inference with minimal performance loss. AWQ quantizes weights post-training using activation aware metrics. So regarding the L4x4 machines which are provided for the competition in this particular competition by the organizers. So these are NVIDIA L4 GPUs which are 2.5 times more powerful for generative AI performance. And these offer 96 gigabytes of memory for submissions with large models. They also provide FP32 um, figure of 30.3 teraflops and FP32 tensor core of 20 teraflops, FP16 tensor core with 242 teraflops. So one can see that we can get very good performance, and for each system is around 24 GB, 4 of them they are providing, so we are getting 96 GB. Memory bandwidth is also high, which is around 300 GB per second. So we now provide the details about the code as we go along, and one of the important aspects about this competition is the management of time. Supposing the notebook exceeds 5 hours using the GPU, then it is going to be timing out, and it becomes invalid, so one needs to be strictly adhering to this guideline. So that's why we track time, and we note down the starting time of the notebook, and the cutoff time is calculated around 4 hours 45 minutes. Then also we have cutoff times for each problems. So there are 50 problems, so we have in this case 51 periods which are marked after 15 minutes. So I have given here. So the total time, because there is startup time for the notebooks, and we have around 4 hours 45 minutes following that for solving 50 problems, and then we have to generate 51 evenly spaced points between the start time and the cutoff time, so that now we can tackle each and every problem and respond to the server. So the model initialization, that is one is that we have to record the path of the LLM model path, and then initialize it. And here the maximum number of sequences is around 32, and maximum model length is computed here 8192 into 3 by 2. And also we use the vLLM to load the model. So the vLLM is initialized like this. The model path is given, then maximum number of sequences is initialized, maximum model length is initialized, then trust remote code is set to true, tensor parallel size, because we are having 4 processors here, GPUs, and 95% utilization in memory is allowed, and in order to have a consistency we also have a seed which is initialized with this value. Then tokenizer is initialized, that's also using vLLM. So the various functions which are there in this particular notebook, which we have submitted for the solution, are listed here. Like one is extract box text. So from the response generated by the model, we need to extract the exact value of the solution. So that is in fact the model boxes the solution, and that solution is extracted by this function. Batch message filter, that is one of the functions which is used to filter the messages and select the answer. This is a very interesting function which does majority voting to select these answer, which is provided by the model. Batch message generate, then there is a function, then create starter message. So this is a function which takes question and index and generates a starter message with prompting. Then predict for question. So this function is repeatedly called to predict for each and every question the solution. And finally we have predict, which is a most important function for submission. So this function is continuously being called. We'll go into all the details about this function. So the select answer function, that is this is a majority voting function which we are using. This in fact counts how many times each integer appears in the list of answers. The integer with the highest count wins, and that's the classic majority voting. So if no valid integers are found, we are also having a fallback of generating a random number in the range of 0 to 999. That is the function select answer is in fact designed to pick most frequent integer from the list of answers with a bit of randomness. The randomness is in order to break the ties. So the tiny bit of randomness is added as here, that is plus random divided by 1000 to each vote. So this in fact helps in breaking ties randomly. So it filters, supposing if many of the answers are getting the same value, then this is useful here. So there's this function also filters any floats and only allows the integers, and this returns the most common integer modulo 1000. So predict for question function, the function takes question and returns an integer prediction by generating multiple LLM responses, filtering their answers and using majority voting to select the final result. So it has a time-based early exit. If the current time has passed a cutoff, so this need to be strictly adhered to, because we should not exceed the cutoff time, and random integer may be generated in case it is not able to give the answer per particular problem within the restricted time. Sequence count adjustment reduce the number of generations if approaching the final cutoff. Then it generates creates multiple prompt variants and sends them back in batch to the model for responses. It also calls the answer extraction and filtering functions. Majority voting, we have seen, applies a noisy majority vote, and it also keeps track of the time progression. And it has 51 entries for cutoff times, and it keeps on popping one of them as it finishes a particular problem. So it finally returns an integer value which is from the range of 0 to 999. So then we have the submission. Submission is supported by this particular API which is provided by the competition, that is AIMO2025 server. So we need to pass the predict function which we have generated, and it wraps the predict function using competition server class, and it takes the environment, and in case if it is found that it is running on the Kaggle competition backend, it calls .serve to run official evaluation. Okay. And if it is running locally, it is checking the reference CSV to simulate the prediction of the test data. So here is the code which we have shown. So it has two conditions. So it takes the environment this thing, and then if it is running in the competition mode, then it's calling this inference server, and if it is running in the local mode, then it is calling the run local gateway and with reference CSV. So the sampling parameters, that is, we define generation parameters for a language model using sampling parameters. This control how the model generates responses. This is used in controlled text generation, like prompting a model to think aloud and then stop at a tag. So in fact, this tag is very important for us. So it's a chain of thought. When the model is thinking, it uses this particular tag to demark the boundaries. Then here is the sampling parameters initialization. We are initializing at a temperature 1.0. So this is in fact one of the trickier parts of adjusting the temperature. That is, if it is too low or too high, the model output may not be consistent. Then we have top P is equal to 0.90, that is 90%. So it is sampling from top 90% of the cumulative probability, and min P is 0.05. We are ignoring tokens with probability below 5%. So skip special tokens is also set to true. Then max tokens, that is constant, which is initialized. Then stop is initialized to this particular special token think, and there is a seed which ensures deterministic output. So the prompting is crucial for the success of this particular notebook, and we have this prompt which is using chain of thought and also ensuring the correctness of the solution. Let me read the prompt. You are an expert trained for mathematics Olympiad level problem solving. Solve the problem using rigorous step-by-step approach. So this is chain of thought. You must give a correct final answer, so we are stressing the correct here. And after solving, review your solution carefully. Avoid overthinking hallucination. One of the problems found in DeepSeek was that it was doing overthinking and not coming out with the solution, so we are prompting the model to ensure that it does not overthink or hallucinate. So as the solution is coming up, the model is advised to analyze the solution to correct any errors or overlooked cases, and it is supposed to return the final solution in box format, so that it also takes the model to 1000. So the solution is in the range of 0 to 999. So for testing the code, we are having 10 published AIMO problems with solutions, so we cross-checked on them. As the code is completed, it is run on these 10 published AIMO problems. Then because the code is outputting submission.paraquet, in fact Python code was required to extract and compare the ground truth solution. So we also debugged the code and also checked for reasoning using these 10 published problems and solutions. Then we submit to the Kaggle server for testing it on the 50 hidden problems. These problems are not known and they are randomly presented to the notebook, and the scoring is automatically done by the Kaggle, and public LB is displayed. So this also gives us an opportunity to ensure that make sure the code runs in 5 hours, as we are using GPUs. And we keep trying different ideas and different models to check the performance. Then we are able to select 2 final submissions that are run by the organizers on private LP. That is the private data set. They are having 50 hidden problems which are randomly randomly presented to these notebook to get the solution. Then the two of the selected submissions are only run for the final private LP scoring, and the scores are given by the candidate. The final results I am presenting here. The competition had gold medal winners, silver medal winners, bronze medal winners, and some top 5 teams which won the prizes, which are in a very high prize amount. The first winner has a private LB score of 34 problems being solved by the model out of 50. Then we have second team which scored 31, then third team 30, and fourth, fifth 29, and fifth 29. So my notebook scored 24 problems out of the 50, and ranking was 141. As it falls in top 10%, it is given a bronze medal. So what we have learned in this particular competition is about the choice of model for this particular application, and we can see that DeepSeek making inroads and being a very competitive model. Then how to fine tune the model for the AIMO problem dataset, the crucial aspect of time management, quantization, then the use of vLLM to do the inferencing in this particular scenario. And among these several models, selection of final notebooks for submission. So conclusions, this is a very interesting and learning experience in participating in this competition. I am glad to be winning the bronze medal with a score of 24, and I also was active in the discussions in this particular competition and won a couple of medals, and I was the first person to bring to the notice of the participants about overthinking problem in the DeepSeek models. I had read it in a IEEE publication about the problems, and so they're handling very complex LLMs with billions of parameters and making use of the GPUs to get the consistent response was a big challenge, and I'm sure the prompting and various underlying techniques are very helpful in bringing the best out of this LLM models. So some of the references are listed here. This is the competition website, and the prize details on this particular website, then the International Math Olympiad website, and the details about the one of the notebooks published which had a higher score, then the API for submitting, and also I have some references about DeepSeek model itself, then the book on large language models, and some exercises on brag and fine tuning and all are listed in this particular cookbook. So I thank the organizers of this particular competition for a very interesting and a challenging competition, and I welcome discussions on this. Thank you.